Hey, Algebra 2 folks, it's Miss Soli here with the very start of Unit 3. This one is all about polynomials. So I'm going to start with 3.1, kind of an intro to polynomials. All right. Oops. Introduction. So a polynomial, poly meaning many. Spelling is going to be my downfall today. Everything's fine. So a polynomial, many nomial can mean like numbers or like many terms. So a polynomial is a function made of terms. Technically, like monomial pieces added together. So a polynomial, there are a couple different types of polynomials that we call out. Monomial, mono meaning one term. So an example of a monomial could be like 3x to the third. Like there's one kind of piece of this function. It could also be like negative 1/4 x to the seventh. Like this is a monomial. There's one piece to this function. I could also have a binomial. Bi meaning two, two terms. X plus 2. Binomial. These are two pieces. I can't combine them. There's no like terms here. It's fully simplified. And in the end, there are two pieces. Could also be like 7x to the 10th plus x to the 6th. Two pieces that I cannot combine. That's a 6. Trinomial is the only other one that we're going to name. Beyond trinomial, I just call it like a polynomial with 4 terms, a polynomial with 5 terms. But tri meaning 3. Most of the quadratic functions we looked at last unit were trinomials. So things like x squared plus 8x plus 15. Trinomial, 3 pieces. I cannot simplify any further. Like I said, beyond that, I just call them polynomials. So pieces. Mono is how many pieces. Binomial, 2 pieces. Trinomial, 3 pieces. But from here, the polynomials have another way to categorize themselves. So this is based on how many terms there are. I can also classify by the degree. And the degree of a polynomial is the highest exponent on a variable. The highest exponent on a variable. So in this case up here, the degree of this was 3. The degree of this is 7. The degree of this, the highest exponent, is 10. The degree of this one is 1. The degree is 2. So the degree is based on your highest exponent. And we'll go through, there's a couple different names for these. I think they'll all fit in a row. We're going to try it. I'm going to start kind of way over here. So first I have what's called a constant. A constant function, the degree is 0 with the constant function. So this one might look like y equals 3. So the graph of a constant function is going to be just a straight line at 3. At 3. Um, yeah, constant function, degree of 0. Then I can have a linear function. This is where my degree is 1. So x raised to the 1, that's going to be your highest exponent. It could be something like 1/2 x plus 6 is an example. Example. Name, degree, shape. Okay. And so these functions, linear function, it's going to have a little bit of a slant. Might look like this. Constant, degree is 0. Linear, degree is 1. We are very familiar with the quadratic from last unit. This is where my degree is 2. So that one can look something like x squared plus 6x plus 8. Something like this. And the shape of this graph is a parabola. Quadratic. Then I've got cubic. So the degree, notice the degree is going up by 1 each time. 0, 1, 2. So for cubic, the degree is 3. So this is where I'm going to have an x with a 3 is the highest exponent. I don't have to have like 4 terms in this. You can if you want to. But something like 4x cubed plus 1, like a binomial. But it's still cubic because the highest degree is 3. This graph would look something like this. Sometimes the little curves here aren't that violent. Sometimes it'll just kind of like squiggle up, but sometimes it'll be really like snaky like that. And then a quartic. Oh, it totally fit. This is my last one. Excellent. This is where a degree is 4. So if the degree is 4, that means my highest exponent is 4, something like x to the 4th plus 3x squared minus 6. Trinomial, but the highest degree is a 4. So this one kind of looks like a W. And again, these like turns in the graph could be less violent or kind of a little bit more subtle. Sometimes it looks like a U with like a longer base of it, depending on how many terms you add to the quartic function. Now, there are Latin names for all of the functions as you keep going with higher degrees. In my opinion, they're not really worth naming because you're just not going to deal with them very often. So beyond 4, I just will say a polynomial with degree of whatever, 5. Polynomial with a degree of 6. Polynomial with a degree of 10. Like, yes, there's a name. I think it's a deca. I have no idea. I have no idea what it is, but because beyond there, we're just not using it very often. So if I say a polynomial with a degree of 5, your highest exponent is 5, 5x to the 5th plus 7. A binomial, but the degree is 5. This graph would look something like this. Now, the reason that we're kind of going through this is when I give you a function or here's an equation to graph, I want you to have an idea in your mind of what that graph is going to look like before we start graphing. These are just very, very helpful tools. So as we're going through these graphs, I want you to notice a pattern, right? So my linear function degree of 1 was going down in one direction, up in the other. Degree of 3 was going down in one direction, up in the other. degree of 5 was going down in one direction, up in the other. So because these are all so similar, I want to come up with a pattern for the degree. Notice these are all 3 odd numbers. The quadratic and the quartic don't do that. So if the degree is odd, if the degree is an odd number, and it really is just like find the highest exponent, is it an odd number? That's really what we're looking at here. Then in the end, like to the right side and to the left side, we'll be going in opposite directions. Right and left sides of the graph will be going in opposite directions. Conversely, oppositeness, if the degree is even, and I'm not going to do the constant function because it's kind of an anomaly, because it doesn't really go anywhere. I don't know. But the quadratic function, both the right side and the left side are going up. With the quartic function, both the right side and the left side are going up. With a degree of 6, that's going to happen as well. With a degree of 8, that's going to happen as well. So if your degree, can you see this pink? Okay, is even, the right and the left sides of the graph will be going in the same direction. Okay, same direction. Now, to tell whether they're both going to be going up or both going down to be down, or down and then up instead of up and then down, to decide when it's going in what direction, that has to do with the leading coefficient. So the leading coefficient is the number that's multiplying the x with the highest degree. Number multiplying the x with the highest exponent. Okay. So the leading coefficient tells us where we're going to be ending on the right side. This tells us where we will end on the right. So in the end, if your leading coefficient, LC, is positive, it's going to be going up to the right. So if this one's going to be a quadratic, they'll both be going up. If it's cubic, it'll be going up in the right. If your leading coefficient is negative, it'll be going down to the right. Let's look at a couple of examples. I don't feel like the definitions of these really give you the clearest picture of it. Okay, so for example, let's say I had 4x to the 4th plus 7x cubed minus 6. So what type of polynomial is this? This is a trinomial because there are 3 pieces. This is a quartic because the highest exponent is 4. The leading coefficient here So what's multiplying x to the fourth is 4, positive 4. So if I'm thinking about my graph before I graph it, because my leading coefficient is positive, I know I'm going to be going up on the right side. Because it is even, I know I'm going to be also going up on the left side. It will look something like this. The other thing with your graphs to notice is how they increase, like how many turns you have. So like on a linear function, I didn't turn at all while I was graphing this, 0 turns as I was graphing. This one, I was coming down and then I turned and now I'm going up. 1 turn. Here I was going up, then down, then up. 2 turns. Down, up, 3 turns. Like I changed directions 3 times. 1, 2, 3. For quintic or degree of 5, 1, 2, 3, 4 turns. So that can also kind of tell you the shape of the graph. Degree is 4, so I knew there was going to be 1, 2, 3 turns. Positive leading coefficient, so it's up to the right. Even degree, so it's up to the left. Let's do one more. Sorry, this video is getting long. Negative 7x to the third plus 6x squared minus 17. Okay. So again, this is a 1, 2, 3 pieces trinomial. The highest degree is 3, so it's cubic because the degree is 3. The leading coefficient is negative 7. Okay, so this means I'm going to be going down to the right. The degree is an odd number, odd degree, so it's going to be going in opposite directions. So the leading coefficient told me it's going down to the right. The degree told me it's going to be opposite. And it's a degree of 3, so I'm going to have 2 turns in my graph. It'll look something like this.